All right, welcome back, everybody.
Welcome back.
Welcome back,
All
Shaq.
right, hope y'all enjoyed lunch. We all on page 6, right?
Yes.
All right, so just to recap before we start moving forward. What's a fossil?
A fossil is a
It's in the book.
a fossil is a
Remaining
injured species, an injured animal that dies and then scattered, like they be eating him and then.
Thank you. All right, long story short, fossils are the remains or traces of once living organisms. They are the remains or traces. So what does it mean to be a trace?
A trace is like there's a trace like a skin or remains on the ground.
So we didn't say remains, we said trace.
Leftover, like you leave something.
Leave something like a what?
Foot trap.
A who?
A foot trap.
Now speak up, you got the mask on.
A foot trap.
What's that?
A foot trap?
A foot trace. Foot trace.
What's that?
Footstep or foot?
Path?
So y'all close. We
Also
said
like
foot something. So if I walk
A record.
and I leave my footsteps, but not quite a footstep, what do you call it?
Footmark.
A mark.
Footprint.
Footprint. You said foot trap.
Wait, so I said foot trap, and then I said footprint.
Okay, so let's go ahead and move forward.
You watched the video?
We watched the video already.
That's new.
Yeah, that's the new video. That's new.
All right, how fossils can form? Can somebody read that for me?
The most common.
How fossils can form, page 6.
How fossils can form? The most common.
Hang on, slow down for me, please.
How fossils can form? The most common fossils form when the remains of dead animals were covered by symptomy. Usually only the hard part of the animal fossilized, but sometimes the soft part fossilized too.
Fossilized too. Did you repeat it?
Yeah.
Okay. All right. So an injured Dorodon nears death. The Dorodon dies and sinks to the ocean floor. Scavengers may eat the soft tissues, or tissues may decompose. Excuse me. The skeleton gets covered by sediments. More sediments buries the entire skeleton. Layers of sediment build up. They turn to rock. The ocean floor becomes dry due to tectonic changes. Erosion exposes the rock layer containing the Dorodon bones. Number 3, review the fossilization progress. Review the fossilization process in the diagram. Which of these conditions might prevent a dead organism from being preserved? We'll take a couple of seconds to look at number 3. Select all that apply, so it might be more than one answer. Somebody read the first step from the diagram. The first step from the diagram.
An injured
Doradon.
near death.
So it's almost dead. What's next?
Doradon died.
It dies and then what? It dies and then what?
Sinks to the ocean floor.
What's next?
Scavengers may eat the soft tissues or the tissue may decompose.
So the soft tissues will be eaten or they're gonna be decomposed, right? What's next?
The skeleton gets covered by sediment.
The skeleton gets covered by sediments. That's just pretty much stuff that's on the ocean floor. What's next?
More sediment buried the entire skeleton. Layers of sediment build up entirely to the ocean floor becomes dry land due to tectonic changes.
Tectonic changes.
Erosion exposes the rock layer containing the neuron's bone.
All right. So, what might prevent a dead organism from being preserved? Show of hands. Being trapped in a tree sap. Will tree sap stop a dead organism from being preserved? Show of hands for yes. Show of hands for no. So again, I didn't have more than half the class. So show of hands. Will it be preserved in tree sap? Show of hands for yes. Show of hands for no. Okay. Being eaten or decomposed. Show of hands for yes. So the question is, which of these conditions might prevent a dead organism from being preserved? So let's start over. Being trapped in tree sap. So will this prevent it from being preserved?
No.
How about being eaten or decomposing? Will that prevent it from being preserved? Being dissolved by water. So
Yes.
what happens to a pill of Tylenol if you put it in water and it's dissolved? It's gone, right? How about being buried by sediments? Now look at the example.
Yes.
Was this preserved? Yes or no? Was it preserved? Yes or no?
No.
It wasn't?
Yes, it was.
So is that going to prevent it from being preserved?
Yes.
It is.
No.
All right. So being trapped in the sap is what's going to protect it. We'll see that on the next page. Being eaten or decomposed. Some animals or decomposers, they don't just decompose the flesh. They decompose and eat the bones too. Some people eat bones from fish. Don't we? We're not supposed to. Being dissolved by water. Once it's gone, it's what? It's gone, right? Oh yeah, that's true too. And being buried by sediments. We know that that's going to preserve it, as we see in the example right here, okay? Let's go ahead and move forward. Ways fossils can form.
Ways fossils can form. It is rare for an organism remain to form a fossil. Many processes of prevent fossil formation. The remains of less than 1% of the species that ever lived fossilized.
Fossilized.
Fossils form more often than an organism's remains are quickly buried by sediment. That is why most fossils are found in sedimentary rock. Quick burial by sediments. Quick burial by sediments occur more often in rivers, lakes, and oceans than it is on land. Therefore, water-dwelling organisms are more likely to be fossilized than land animals. Fossils may form more form more an organism bones, teeth, and shells. They may also form from active fossils of soft-bodied animals such as jellyfish or whales, but they do exist. Protein and genetic materials may also fossilize. For example, scientists identify certain cells, structure, and fossilized features that help them determine the color of the feathers.
All right, so is that just one way for fossils to become fossilized,
No.
or is it many? Um, where do they form from? You want to spit it out?
Organism bones,
Organisms, bones,
teeth,
teeth. Anybody else?
shells.
Shells. That's part of your bones. Um, what about fossils that don't have bones, like jellyfish? Do they have fossils?
Yes, but they are really rare.
Are they really rare? Okay. Let's see. Page 7. How many different types of fossils do we see?
Oh,
How many different types? 7. So we got permineralized fossil. Can we say permineralized? Per mineral. Permineralized. Please don't jump ahead of me. Please don't. Carbonized fossil. Carbonized fossil. We have amber fossil. Cast and mold fossils. Hold your head up, man. Hold your head up. Trace fossil. Tar pit fossil. And frozen remain. All right. Permineralized fossil. Permineralized fossil. Anybody want to read about permineralized fossil? Slow down. Permineralized.
Mineralization happens when organisms' tissues are replaced by minerals and water. These minerals form a hard, three-dimensional copy of the original organism. The bones and feathers of this
Archaeopteryx.
archaeopteryx.
Everybody, Archaeopteryx.
Archaeopteryx are permineralized.
Okay, so with the permineralized fossil, what's happening with organisms' tissues?
are replaced by minerals and water.
They're being replaced by minerals from water. And what are they pretty much making?
Three-dimensional copy.
A 3D copy. Carbonized fossil.
Carbonized fossil. A carbonized fossil forms when an organism, usually a plant, is quickly buried and flattened by the enormous pressure of sediment built up above it. Most of the nitrogen, oxygen, and hydrogen that made up the organism get removed. Only the carbon from the organism remains as a thin black film. These firm leaves are carbonized.
So, what type of organism are usually carbonized? Let somebody answer. Okay, plants. And we just talked about sediments. Where do you usually find sediments? Where can we find sediments? What about the well? Think about the well. Where was the well? In water. Give me an organism that's in water. That's a plant. Algae. So algae is something that can be carbonized, right?